Hello everyone, welcome to my chemistry channel B.L.DASH short and sweet in chemistry. Now I am going to explain the chemical reactions involved in the properties of alkene. And now in my previous videos already I have explained the preparation of alkene, the reaction involved in the preparation of alkene. Also here I will explain addition of hydrogen halide to alkene. Here you can see this is the alkene skeleton where you will add HX, that means here hydrogen comes to here, X comes to here, or you can write X here, hydrogen here, there is no problem. There is only possible for the symmetrical alkene. What is symmetrical alkene? I will tell later. Now here you can see hydrogen is added. Now you can observe also the valency of carbon is satisfied. What is the valency of carbon? 4. So see 1, 2, 3, 4. 1, 2, 3, 4. That means the skeleton is correct. And now when HX is added, hydrogen comes to here, X comes to here, and double bond changes to single bond. That means you can find all are containing single bonds. So here 1, 2, 3, 4. That means carbon is satisfied 4 valency. 1, 2, 3, 4. This carbon also satisfied by 4 valency. So there is no problem, there is no wrong in the naming of the alkene. Now reactivity. You know there are so many types of hydrogen halides are there. HCl hydrogen chloride, HBr hydrogen bromide, HI hydrogen iodide. But here the reactivity is HI is more reactive than HBr than HCl. That means HCl is less reactive towards the alkene. Actually generally almost all reactions, addition reaction with hydrogen halide takes place by the help of HBr. So this is one type of electrophilic addition reaction. Yes, this reactor is only possible because iodine size is large, so it can break easily, and then bromine, then chlorine. So this is called electrophilic addition reaction. What is meant by electrophilic addition reaction? First you should know what is mean electrophile. Electrophile means electron loving. That means who will love electron? Electron itself negative charge. That means electrophile should be a positive one so that it will attract, it will add to the alkene. So the mechanism in later video you will see what is the electrophilic addition reaction, what is the mechanism. Then what is meant by symmetrical alkene? I told alkenes here contain double bond, okay. But if you see before double bond water present and after double bond water present, how many carbons are there, how many hydrogens are there, from that you can decide whether it is symmetrical or unsymmetrical. First we will see what is meant by symmetrical alkene. You know alkene contains double bond. Now double bond is there and same number of carbons and hydrogens on both sides of the double bond. If double bond in the middle, if double bond is there, you will observe what is the number of carbon and hydrogen and what is the number of carbon and hydrogen. Here you will observe what is the number of carbon and hydrogen, and here also you will observe what is the number of carbon and hydrogen. If they are same in number, then it is called symmetrical alkene. I hope it is clear. Symmetrical alkene means it contains double bond. Before and after double bond, you will observe what is the number of carbon atoms and hydrogen atoms on both sides. If they are same in number, then it is called symmetrical alkene. Now simple example, ethene. You know ethene. What is the structure? CH2 double bond CH2. See, before double bond 1 carbon 2 hydrogen, after double bond 1 carbon 2 hydrogen. So it is a symmetrical alkene. Ethane, that is called ethane. Ethane plus HBr, you can add either hydrogen here or here. It is your choice, no problem. Because it is symmetrical alkene, you can put hydrogen here, Br here, or you can put hydrogen here, Br here, no problem. Same product you will get, that is CH3, CH2, Br. So here in symmetrical alkene you can observe the addition takes place on both sides of the double bond, and you can observe here H is one side, Br is the other side, then it produces CH3, CH2, Br. What is the name? Ethyl bromide. What is the IPS name? Bromo ethane. Why ethane? Because there are two carbon and it is the bromine is substituted by hydrogen. That is why it is bromoethane. Now here next is but2-ene. What is but2-ene? 2-ene means the double bond should be present in the position that is after the carbon 2. After the carbon number 2. That means here you should count 1, 2, 3, 4 or you can count 1, 2, 3, 4. There is no problem because in either side you try to get the number that is 1, 2. After 2 there is a double bond. You can count from this side or this side. 1, 2, 3, 4. That means here it is but2-ene. Now it is a symmetrical alkene because you can count here 1, 3, 4. 4 hydrogen and 2 carbon. Here also 4 hydrogen and 2 carbon on both sides of the carbon atom. That is why it is a symmetrical alkene. In symmetrical alkene, when you are HBr, you can write H right side, Br left side, or you can write H right side and Br left side. There is no problem. The product only you will get 2-bromobutane. 2-bromobutane. Why 2-bromobutane? 1, 2, 3, 4 in 2 position the bromine is there. Why you will not count from this side? 1, 2, 3. It is wrong. Why? Because the substituent group which is near to the side, you will count from that side. Number 1, number 2, number 3 like this. Now bromine, if you say from this left side, this is the number 2 position. If you count from right side, 1, 2, 3. In 3 position there is a bromine. That is why correct is 2-bromobutane. I hope it is clear. Again you see, if the double bond, that is the skeleton of alkane, where HX is added, this is the product, that is alkane. Substitution of alkane. Now reactivity HCl, HBr, HI. HI is more reactive than HBr than HCl because size of iodine is more than Br than chlorine. So it is easy to break that HI bond. Now electrophilic addition reaction, these are the electrophilic addition reaction because here electrophile is formed which contains positive charge. The mechanism we will see in later videos. Now unsymmetrical alkene, there are two types of alkene, symmetrical and unsymmetrical. Now we will see symmetrical. Symmetrical means the double bond, both sides of double bond, the same number of carbon and hydrogen should be present. Now I have explained here, this is double bond, carbon hydrogen same to this one. Simple ethene, because it is symmetrical alkene, HBr is added, so the product is CH3, CH2, Br. If you take but2-ene, that is also symmetrical alkene because you can observe here it is 2 carbon, 4 hydrogen. Right side also 2 carbon, 4 hydrogen, and this is between double bond present. That is why it is but2-ene, and addition reaction takes place and the product is 2-bromobutane. Here other reactions also will say what is unsymmetrical alkene, how the reaction takes place, addition reaction takes place in unsymmetrical alkene we will see. I told about symmetrical alkene. What is symmetrical alkene? On both sides of the double bond, the same number of carbon hydrogen present. But what is unsymmetrical alkene? In unsymmetrical alkene, the number of carbon and hydrogen are different between on the both sides of the double bond. On the both sides, they see here, example CH3, CH double bond CH2. You can see this side only 1 carbon and 2 hydrogen, and this side 2 carbon, 4 hydrogen present. That is why it is called unsymmetrical alkene. You can observe different number of carbons and hydrogen on both sides of the double bond. This is the double bond, this is one side, this is one side, this is the left side, this is right side. In right side 1 carbon, 2 hydrogen, in left side 2 carbon and 4 hydrogen. So if in the unsymmetrical alkene HBr, that is hydrogen halide, is added, there are 2 possible products. How? Because if HBr, here H is added, Br is added, this is one type of product, that is 1-bromopropane. if you add bromine here, then the product is 2 bromopropane. There are two possible products. One is 1 bromopropane and other one is 2 bromopropane. Then which one is the correct one? Which is the major product? Which is the minor product? Now here you can observe this is called unsymmetrical alkene. What is that? Propene. So here when the two products forms, the scientist Markovnikovs who said about his rule. The rule is said that the negative part, you know, hydrogen halide, there is one negative part or there is positive part. The negative part goes to the carbon atom which has less hydrogen atom, which has less. Now say how many carbons are there? 1, 2, 3. In one position, so this is one position. In one position there is 2 hydrogen and here 2 position there is 1 hydrogen and here 3 position there are 3 hydrogen. So according to Markovnikovs rule, here which is the less hydrogen atom, lesser number of hydrogen atom which has, this is number 2 carbon has lesser number of hydrogen when you compare to 1 and 3. So the negative part goes to the carbon which has lesser number of hydrogen atom and the positive part will go to other carbon. That means Br goes to here 2 number position carbon and hydrogen goes to here which is the carbon 1 position. That means here this is called Markovnikovs rule. What is Markovnikovs rule? The negative part of the addition product that is called addendum and here the negative part goes to the carbon which has less number of hydrogen atoms and positive part goes to the opposite, that is after the double bond. After the double bond here it is one present, here it will go. That means here it is Br goes to here and hydrogen goes to here. Now example you can see, this is called propene plus HBr. Then what is the product? The Br. Where Br will go? Br comes to here and here the hydrogen goes to here. That means this is called Markovnikovs rule. So the product is CH3, CHBr, CH3. That is called 2 bromopropane. It is called 2 bromopropane. Now it is here example, what is that one? 1, 2, 3. 2 position methyl group and after 1 there is a double bond. So the name is 2 methyl propene. What is the name? 2 methyl propene plus HBr, then Br will goes to where? The negative part will goes to the carbon here. The negative parts goes to this carbon and positive part, that hydrogen, goes to this carbon. So the product is, you can observe CH3, C, Br1 substituent, CH3 1 substituent and in this side CH3 long chain. What is the long chain here? Propane 1, 2, 3, 3 carbon. And what are the position occupied by the substituent? 2 position occupied the bromine and 2 position occupied by the methyl group. So what is the name? 2 bromo, 2 methyl. Why 2 bromo? Why not 2 methyl? Because 2 bromo, bromo is alphabetically first. Bromine B. So 2 bromo, 2 methyl propane. Why propane? Because the long chain is 3 carbon and the house itself, the parent hydrocarbon itself propane. In propane, 2 positions are occupied, hydrogen is replaced by bromine and methyl. That is why the name is 2 bromo, 2 methyl propane. Now here but 1 in, you can observe here also right side 1 carbon 2 hydrogen and left side 3 carbon and 6 hydrogen. So but here which one is the lesser number of hydrogen atoms? This one, 1, 2, this CH, because CH only 1 hydrogen and here it is 2 hydrogen. So the bromine will comes to here. Bromine comes to 2 number position carbon. So what is the result? CH3, CH2, CHBr. Because in CH, Br is attached, Br is added. In carbon 1 position carbon, hydrogen is attached. So here the first structure is CH3, CH2, CHBr, CH3. What is the name? You will count from this side or that side. You will count from this side. Why? Because the substituent is near to that side, right side. So 1, 2, 2 bromo, 2 bromo butane. What is the name? 2 bromo butane. So this is called Markovnikovs rule, and by Markovnikovs rule only unsymmetrical alkene that gives the product with the help of Markovnikovs rule. According to Markovnikovs rule, the negative part goes to the carbon which has less number of hydrogen atom, and that hydrogen comes to the other carbon after the double bond. So we will come to anti-Markovnikovs rule. You know Markovnikovs rule is that one. But what is anti-Markovnikovs rule? Anti-Markovnikovs rule that is called Khara's effect. That is, here it will not follow Markovnikovs rule, that is called anti-Markovnikovs rule. Then when and why and where. You will see now what is the anti-Markovnikovs rule. I told about Markovnikovs rule. What is Markovnikovs rule? The negative part goes to carbon which contain less number of hydrogen between the double bond. That means Br, if HBr, Br comes to carbon which contain least number of hydrogen atoms. Now we will see what is anti-Markovnikovs rule. Anti-Markovnikovs rule, that means the scientist Kharash, he said about this, and that is called also Khara's effect and peroxide effect. Because in anti-Markovnikovs rule we will use that is benzoyl peroxide, that is why it is called peroxide effect. In the presence of benzoyl peroxide, the totally product is changed, reverse to Markovnikovs rule. Markovnikovs rule say the negative part goes to the carbon which contain least number of hydrogen, where it says just opposite to Markovnikovs rule. What it say? Bromine atom, the negative part goes to carbon which carries more hydrogen atom, and the hydrogen atom comes to the other atoms of double bond. When you see double bond, the one side where more number of hydrogen bromine will attach, other side where the hydrogen is attached to that double bond side. Now you can see this is called Khara's effect, this is also called peroxide effect. And why it is called anti-Markovnikovs rule? Because what Markovnikovs rule say, it will not follow, it will do, this rule do opposite to that Markovnikovs rule. What Markovnikovs rule say? Bromine, that negative part goes to the carbon which contain least number of hydrogen, whereas anti-Markovnikovs say that the negative part will go to the carbon where the more hydrogen atom present between the double bond. Now here example you can observe CH3 CH2, this is unsymmetrical. You add HBr. If you will write peroxide here, if you will add peroxide here, the product totally change. Bromine comes to carbon which contain more hydrogen between double bond, one side CH, other side CH2. So Br will go to the carbon which contain more number of hydrogen. So Br comes to here and hydrogen comes to here. Now here hydrogen comes to here and Br comes to here. Now what is the name? 1-bromopropane, whereas when anti-Markovnikovs rule will follow, at the time 2-bromopropane observed, and whereas anti-Markovnikovs rule, that is peroxide effect, when you add peroxide, benzoyl peroxide, the product is 1-bromopropane. This is very very important, that Markovnikovs rule, anti-Markovnikovs rule, and what are the product in both case is very very important for the examination point of view. Now you take 2-methyl propene, here also the number of carbon hydrogen are different, that is why it is unsymmetrical, and you are adding peroxide, so it will follow anti-Markovnikovs rule, that is opposite to Markovnikovs rule. So Br will come to where Br will come to this hydrogen where there is more hydrogen. So Br will come to here, Br will come to here where hydrogen will come to here. So what is the product? CH3 CH branch CH3 CH2 Br. That means it will follow Markovnikovs rule, because you are adding peroxide. What is that peroxide? Benzoyl peroxide. So the product is 1 bromo, 2 methyl and 3 carbon propane. So 2 methyl propane. I hope it is clear. Again see, Markovnikovs rule, you will not use benzoyl peroxide. Anti-Markovnikovs rule, you will add peroxide, that is benzoyl peroxide. It will just do opposite to the Markovnikovs rule product. So here the negative part will go to the hydrogen, where the that is more hydrogen present, and the hydrogen comes to the carbon which contain less number of hydrogen. That means here you can see propene, this side is more hydrogen, bromine will come to here, and the opposite side hydrogen will come to here. This is the double bond. And similarly here also bromine comes to here and hydrogen comes to here. So these are the products. I hope it is clear what is Markovnikovs rule and anti-Markovnikovs rule, and this is very important. Hope you will subscribe my channel B.L.DASH short and sweet in chemistry, and also please like and share my channel. Thanks for watching my video. Next coming video I will explain different addition reaction. The addition reactions where it always follow Markovnikovs rule and anti-Markovnikovs rule, not only for hydrogen halide, it also follow for the water, sulphuric and other products, other addition reaction. So thanks for watching my video again to all.